All right. So the first question is probability that an ordinary, or I can call it as a non-leap year, has 53 Sundays is, right? Okay. Now if you see, a leap year has how many days? Yes, Ritvik? Aditya, you can message. Yeah, leap year has 366 days, correct? Non-leap year or an ordinary year will have how many days? 365 days, isn't it? So an ordinary year will have 365 days. And if you divide 365 by 52, right, you will get 52 full weeks. Plus 1 day. Because 52 into 7 will be equal to 364. Correct? So plus 1 day, right? So now if you look at this, in 52 full weeks, how many Sundays will be there, Jerome? 52 full weeks are there. So how many Sundays will be there in 52 weeks?
53, sir.
In 52 weeks, you have 53 Sundays? Evelyn, in 52 weeks, how many Sundays you will have?
52, sir.
Exactly, right? This 1 day, we don't know what day it will be, right? So that 1 day it can be either a Sunday or a Saturday, or I can go in order. It can be either a Sunday or a Monday or a Tuesday, Wednesday, Thursday, Friday, or a Saturday. How many possibilities are there, Evelyn?
7, sir.
Yeah, so the number of elements in the sample space is 7. And I want that day to be a Sunday, isn't it? So that already 52 Sundays are there, plus this 1 day is also a Sunday, then it will become 53 Sundays. That's what we want. So the required event is that day is a Sunday, right? So number of elements in set A is 1. Therefore, what is the required probability? 1 divided by 7. Did you understand, Jerome?
Yes, sir.
Yeah, in 52 weeks, how many Sundays will be there?
52.
Yeah. In 52 weeks, how many Mondays will be there? Keep yourself on unmute. 52 weeks are there means how many Mondays will be there?
52, sir.
Yeah, where are you thinking? In 1 week, how many Mondays are there, Jerome? In 1 week.
1 Monday, sir.
That's all right. So 52 weeks means how many Mondays will be there?
52 Mondays.
That's all. Are you clear now? That extra 1 day, what is the probability that it is a Sunday? So that is 1 by 7. Okay, done. So shall we move on to the next question? Okay, now question number 2. 3 letters are to be sent to 3 different persons, and addresses on the 3 envelopes are also written. Without looking at the addresses, what is the probability that the letters go into the right envelope? Options are 1 by 27, 1 by 9, 4 by 27, 1 by 6. Can you try this for a minute and then we will discuss? So there are 3 letters which are there, right? Letter 1, letter 2, letter 3, let's say. 3 different letters, and we have 3 different envelopes, right? Now addresses are written on them, right? Let's say one is addressed to your relative, maybe one is addressed to your friend, one is addressed to your, school, right? Now point is, how many ways of correctly placing these letters, letters into the envelope? There can be how many ways? Yes, Evelyn? Can you unmute me?
Yes, sir.
How many ways can I place them in the sense correctly? For correctly placing them, how many ways are there?
3 ways, sir.
Correctly placing them, there is only one way. The principal's letter should go to principal, friend's letter should go into friend's envelope, and your, let's say, your relative's letter should go into relative's envelope, right? So there is only one possible way, right? You can't change that. So there is only one possible way. So the number of ways which are favorable is 1. Do you get that, Evelyn?
Yes, sir.
Yeah. But how many total number of ways? I don't care about which letter getting into which envelope. If I randomly do it, how many options are there for you, Evelyn? Okay, let's take the first letter, okay? You take the first letter. And now, how many options are there for you?
3 options.
Exactly, right? And then you placed one letter in one envelope. So that's over, right? So the second letter you're taking, how many options do you
3
have?
factorial, sir.
Exactly, right? So you have 2 options, and for the other one, you have 1 option. So total number of ways in which you can place the letters in the envelopes is 6. So the total number of ways, if you see in the sample space, is 6. So your required probability is going to be 1 divided by 6. Is it clear, Evelyn?
Yes, sir.
Yeah. Hrithwik,
Yes, sir.
did you understand, Hrithwik?
Yes, sir.
Okay, what about Jerome?
Yes, sir.
Okay, Aditya? Yeah, Enoch, come on video, ma. Fuzail, come on video, ma. Okay, let's move on to the next question now. Okay. I'm throwing a coin, fair coin. How many times I'm throwing the coin? Or a throw of 3 coins. I'm having 3 coins and 3 coins are being tossed simultaneously. Can you tell me how many outcomes will I have in the sample space when 3 coins are tossed?
8.
Very good, Enoch. Yeah, 8. So can you list what are the outcomes?
All the outcomes, sir, or just the
Yeah,
desirable
all the
one?
outcomes. Can you? Yeah,
Head, head, head. Tail, tail, tail. Head, tail, head. Tail, head, tail.
yeah,
Then tail, head.
yeah. Now out of these, so number of elements in the sample space is 8, right? Now I want to get head and tail alternately. In which of the options do we have that happening?
So 2 options, sir.
Exactly, 2 of them, right? HTH and THT. So the number of elements in A, which is the required event, is 2. Therefore, the required probability is 2 divided by 8, or I can say 1 upon 4, which is the second option. Is this clear, everybody? Yes, Evelyn, is it clear?
Yes, sir.
Yeah, Aditya, Jerome, Ritvik.
Yes, sir.
Okay, good. We'll move on now. Next question, question number 4. Among 15 players, 8 are batsmen and 7 are bowlers. So we have 8 batsmen. And bowlers we have 7. And totally, so we have in total we have 15 players. Now we want to make a selection, right? I want to choose 6 batsmen and 5 bowlers. Okay. Let's say one of them is a keeper. Okay. So I want to select 6 batsmen and 5 bowlers, right, for my team. Let's say we are selecting a cricket team. Okay. Now, what is the probability of the team having 6 batsmen and 5 bowlers? So what is the total sample space? Can you tell me? I'm having 15 people, and from 15 people, I'm going to select what? I want 6 batsmen and 5 bowlers. So totally, how many people am I selecting?
11.
Yes. From 15, I'm selecting 11. So how many ways can we do that, Jerome? From n things, we are selecting r things. From 15 players, we are selecting 11 players. We can do that in 15 C11 ways, correct? Right? So that is the sample space, okay? That's the number of options that we have. So it's 15 C11. Okay, now let's look at what we actually want. We want 6 bowlers, 6 batsmen, and 5 bowlers to be selected. So I have 8 batsmen. From that, I'm going to select 6 batsmen. So how many ways can I do that, Jerome?
8C6, sir.
Very good. So I can select 6 batsmen out of 8 batsmen in 8C6 ways. How many ways can I select 5 bowlers from 7 bowlers?
7C5, sir.
Correct. Now, I'm selecting the batsmen and I'm selecting the bowlers. So whenever I have and, what is the operator that I use?
Multiplication, sir.
Very good. Excellent. That's all. Therefore, my required probability is going to be n of a divided by n of s, which is nothing but 8C6. That means I'm selecting 6 players, 6 batsmen from 8 batsmen, and I'm selecting 5 bowlers from 7 bowlers. Totally, I'm selecting 11 players from 15 players. So which option is correct, Jerome? Yes, Enoch, which option is right?
A option.
Yes, absolutely. All right. So let's move further. Okay. I'm going to have a single throw of 2 dice, right? So when I throw 2 dice, Enoch, can you tell me how many outcomes will I have in the sample space?
2 raised to 6, sir.
No, not 2 raised to 6. 6 raised to 2. When I throw 1 die, the number of outcomes is 6, right? So I'm throwing 1 die and another die. So 6 into 6, 36. Can you list the outcomes, Enoch?
So 1, 1, 2,
Exactly, right. 1, 1, 1, 2, etc. up to 1, 6. You know it very well, all of you.
3. Yes.
2, 1, etc. up to 2, 6. 3, 1, etc. up to 3, 6. 4, 1, up, etc. up to 4, 6. 6, 1, etc. up to 6, 6. Right? So these are the outcomes in the sample space, correct? And I want to get the sum as 8, right? That's the favorable outcome. So can you tell me which all will contribute to 8?
1625.
1, 6,
Sorry, 163. Sorry, 17.
7 do you have when you throw the die?
Oh no, sir. Sorry.
Yeah, go ahead.
Oh.
Come on, you need to add them and you
Actually,
should get 8.
yes, sir. Okay, so 3 2
3, 2.
6 2
Ah, right.
6 2.
2, 6, 6, 2, isn't it?
Yes.
Then
Then 5 3 and 3 5.
correct. One more.
Then 4 4.
That's
Yeah,
it.
4 4.
So how many outcomes are there which we want?
5, sir.
5. And how many outcomes totally?
36.
So totally we have
36.
36 outcomes, right? So what will be my required probability?
5 by 36.
Exactly. So that will be my second option. Is it clear? Everyone, is it clear? Okay. We'll move on further. Okay, we have just 1 minute. Please go through the next question. We'll discuss it. Okay, next question. Let's look into this. 3 mangoes and 3 apples are in a box. If 2 fruits are chosen at random, what is the probability that one is a mango and the other is a apple? So let's say here I have 3 mangoes and 3 apples. So totally there are 6 fruits, right? And how many fruits am I going to select? 2 fruits from them. So the total number of ways in which I can select 2 fruits from 6 fruits. Can you tell me what it's going to be, Jerome? I'm selecting 2 fruits from the total of 6 fruits. How many ways can I do it?
62, sir.
Very good, very good. 6C2, correct? Okay. Now, one fruit should be mango, one fruit should be apple. So, from 3 mangoes, I have to select 1 mango, isn't it? So, what will be the number of ways, Jerome?
3C1, sir.
Very good. That's for the mango. Now, I want to select apple. 1 apple from the 3 apples. What is it going to be?
3C1, sir.
Very good. And what should I do to these 2 numbers?
Multiply.
Very good, because I'm taking 1 apple and 1 mango, isn't it? So that's it. Very good. So if you see 3C1 is 3, 3C1 is 3 divided by 6C2. 6C2 is nothing but 6 into 5. You have to reduce to 2 numbers, then divided by 2 factorial. That's the shortcut, right? 30 by 2 will be 50. So what's your answer? Three by 5. So do we have the option? Yeah. So the right answer is going to be 3 upon 5. Is it clear, everyone? Any doubts, Evelyn?
No, sir.
Clear, right? Hrithwik, Aditya, Jerome, Zain.
No, sir.
No, sir.
Okay. All right, good. Have you noted down, Jerome?
Yes, sir.
Okay, we'll move on. Okay. Similar question. See, these questions you can use permutation combination, or you can directly also do. So you have 5 white balls, 7 black balls, and 4 red balls are there. Yes, Hrithwik, can you answer this, Mark? Can you unmute yourself?
Yes, sir.
Yeah, totally how many balls are available?
16, sir.
Yeah, 16 balls are there totally. And out of that, how many balls are being drawn?
3, sir.
Yeah. So we are drawing 3 balls, right? So now, what is going to be the total number of ways in the sample space? Number of ways, n of s. From 16, we are drawing 3. So
So
how do I write it?
16, 3,
Yeah.
sir.
16?
C3.
Perfect. Perfect. Okay. Now, I want all the 3 balls to be white, right? That means all the 3 white balls have to come from what?
White. Fire.
White balls. So, what is n of a? Can you tell me?
5C3, sir.
That's it, ma. We are not picking any black ball or white ball. Therefore, it is only 5C3. Therefore, your required probability is nothing but n of a divided by n of s, isn't it?
Yes, sir.
So, it is 5C3 divided by 16C3. 5C3, you can calculate it. It will be 10, right? 5 into 4 divided by 2, it will be 16C3 will be what? 16 into 15 into
15.
14. You have to do it 3 times. Then divided by 3 factorial. That 3 factorial, I will take it to the top. Right? So this is 2 times,
Yes,
this is
sir.
3 times. If I divide by 5, 3 and 3 cancels. 8. Are we missing anything? 1 second. Yeah, 2 and 14 I can cancel, 7. Yeah, 1 by 56 it will be.
Yes, sir.
Yeah. Are you getting 1 by 56, everybody? Yes, Ritvik?
Yes, sir.
Yeah, Jerome?
Yes, sir.
Okay, Aditya? Yeah, Evelyn, clear? Okay. I hope you have noted down. Okay, now next one. Similar question. So can you all, can you do this now? Exactly similar question. Please try and tell me. What's the answer, students? Yeah, Evelyn, unmute and
Sir, 2 by 17.
yes, yes. Aditya, are you also getting the same? Okay. See here, exactly same process. Yes, Hrithwik, can you unmute me?
Sir.
Yes, ma'am. In a pack of cards, how many total cards are there?
52, sir.
52 are there, correct? Okay.
Yes, sir.
So there are 52 cards in the pack. And how many red cards do we have? Do you have an idea? Yes, Ritvik?
Yes, sir.
How many red cards we have? How many black cards we have?
Sir, 23?
26, half of it, half of it.
Okay. 26.
26 red cards will be there, 26 black cards will be there. Is it clear?
Yes, sir.
Okay. Now, I'm going to pick, see here, what is the probability of picking one red card? Favorable outcome is what? or I will answer it directly, okay, like what we have done previously, okay. Now see here, from 52 cards, how many cards I have to pick, Ritvik?
3, sir.
3 cards. So what will be my N of S? Can you tell me?
52C3, sir.
Exactly, ma. Very good. Okay, now all those cards have to be red cards. Is it clear?
Yes, sir. 26C3.
Very good. That's all. So what is my probability, Ritvik?
Sir, 2 by 17, sir.
Correct. So that's basically 26C3 divided by 52C3. We just have to simplify this. That's it. I'm sure you can do the simplification.
Yes, sir.
Three factorial gets cancelled. 25 and 50 you can cancel it 2 times. 26 and 52 you can cancel it 2 times. 24 and 4 you can cancel it 6 times. So you are getting 6 by 51. But 6 you can write it as what? 2 into 3. 51 you can write it as 3 into 17. So answer is 2 by 70. Correct?
Yes, sir.
Yes. Good. Good. Okay, we'll move on to the next question now. A straightforward question. I think in a second you can answer this question, right? For any event A, what is P of A plus P of A bar? 1, isn't it? Happening of an event or not happening of an event. One of them will surely occur, right? So the right answer is 1. P of any event plus the probability of its complement will always be 1, because say for example A refers to passing the exam, right? A bar refers to failing the exam. So a student will either pass or fail for sure, correct? So that's the meaning. Okay, fine. Let's move on to the next one now. Please go through this. A card is drawn from a well shuffled pack of cards. The probability of getting a queen of club or a king of heart is, right? So total number of cards. Yes, Jerome, can you unmute me?
Yes, sir.
How many cards do we have?
52, sir.
52 cards we have, correct? Now here we are only picking one card. Okay, so okay. Now tell me one thing. Club cards, how many we have?
13, sir.
Very good, ma'am. Queen cards, how many we have?
4.
Club queen, how many we have?
4 no, sir.
No. Queen cards, 4 are there, no? What are those 4? Club queen, diamond queen, heart queen,
Spade.
spade queen. Correct or not? So 4 queens will be there. So in that club queen, how many?
1, sir.
Only 1, right? So number of, let me call it as club queen, only 1, isn't it? Similarly, how many kings do we have totally?
4, sir.
Yeah. How many kings of heart we have?
1, sir.
Only 1, isn't it? Right. So now tell me, Jerome, what is the probability of drawing a club queen?
1 by 52, sir.
Very good, very good. What is the probability of drawing a king of heart?
1 by 52.
Yes. What is the probability of drawing a queen of club or a king of heart? Or means what you should do, Jerome?
You have to add, sir.
Exactly, ma. And there is no intersection. A same card cannot be both queen and heart, queen and king, correct? Therefore, there is intersection is 0. So you can directly add them. So what do you get, Jerome?
2 by 52.
Exactly, 1 by 52 plus 1 by 52, 2 by 52, or I can say 1 by 26 is the answer. Is it clear?
Yes, sir.
Okay, ma. Hritvik, is it clear, ma?
Yes, sir.
Yeah, Evelyn, Fuzail, Zain.
Excuse me, sir.
Yes, Evelyn.
Sir, can you explain how probability of drawing Queen of Club is 1 by 52, sir?
Evelyn, how many queens do we have, Evelyn?
4, sir.
4. And how many club queens we have?
1.
1, correct. So suppose if I have 4 queens and totally 52 cards are there, what are the probability of drawing a queen in general?
52C4.
No, 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 no. No, no, no. I'm asking you. We are not taking 4 cards. I'm asking you the probability of drawing a queen.
52C1.
No, that is from 52 you are taking
4C1.
4C1 in the numerator. So it will be 4 by 52, right?
Yes, sir.
Correct, Evelyn? Is it clear?
Yes, sir.
Yeah. Now, when I say club queen, how many club queens are there?
1.
So what will be the probability of drawing that club queen? Number of ways is 1C1.
Sir, I didn't get you.
Okay, no problem. So whichever way you can understand it from with combinations or without combinations also, no problem. Yes,
Sir, I actually did it as 13C1. Like,
where is
from the
13?
club.
No, no, no. 13C1 will come when you can pick any club card. 13C1 will be the answer if I had given instead of this, if I had said number club, you pick any club card, then you can pick a queen club card or a king club card or a jack club card or 2, 3. You got the point, Evelyn? You will get 13 options, isn't it?
Sir, so you're selecting that Queen of Club from the entire 52 cards.
Yes. How many queen of clubs are there?
1.
1. Therefore, it is 1 by 52.
Okay, sir.
Is it clear now, Evelyn? Same for king of heart. And there is no common intersection. Therefore, or represents union. That simply becomes addition. M. Okay. Shall we move on to the next question now? Okay. Very simple question. Please try this now. Yes. Yes, Evelyn. What is the answer, Evelyn?
Sir, 3 by 10.
Perfect. Perfect. Right. So what is P of A union B, Evelyn?
P of A plus P of B minus P of A intersection B.
Correct. So that is the general formula, right? And what does A intersection B represent, Evelyn?
0, sir.
In the sense, that's correct. So can you explain what is A intersection B?
The common values of A and B.
Or you can say the probability of occurrence of A and B
A and
simultaneously
B together.
together. And when I say two events are mutually exclusive, that means the occurrence of one will prevent the occurrence of the other.
Yes,
So
sir.
A and B cannot occur together, right? When the two events are mutually exclusive, A and B can't occur together. Of course, mathematically we understand P of A intersection B will be 0 because it can't occur together. So it's simply P of A plus P of B. Very good. Therefore, 0.7 will be equal to 0.4 plus X. Therefore, X will be nothing but 0.7 minus 0.4, which is 0.3. And 0.3 is nothing but 3 by 10. So first option is correct. I hope it's clear, everyone. Okay, we'll move on further. Okay, this is a question which combines here conditional probability and dependent and independent events. But very simple. The moment you see the first definition, you understand something here. Jerome, can you unmute me?
Yes, sir.
Yeah. So can you tell me what this means, what I've written here?
P of A given B, sir.
Yeah, what is the meaning of that? Probability of the occurrence of event A, given that, how do you read it?
A probability of A given that B has already occurred, sir.
Excellent. B has already occurred, right? And that is given to be equal to P of A itself. Are you able to see me?
Yes, sir.
So what is the meaning of this? When I have something like this, P of A given B is equal to P of A, what it means?
Dependent, sir.
Are they dependent? In fact, P of A, given that B has happened, is directly equal to P of A means, does it depend on B?
No, sir.
No, right? So here itself you can decide, even before going into this number, you can decide that A and B are independent. Because P of A, given that B has happened, it doesn't matter at all. It's simply equal to P of A. Did you get that, Evelyn?
Yes, sir.
Good, ma. Yes, Ritvik?
Yes, sir.
Aditya? Okay. So that value is equal to 1 by 4. Okay. Now one theorem is there, which you have. If A and B are independent, then A and B dash are also independent. A dash and B are also independent. A dash and B dash are also independent. All these pairs are independent. If A and B are independent, then all these other pairs are also independent. Okay. So now from this information, can you tell me, yes, Evelyn, can you tell me what is actually P of B given A? Since they are independent, what can I call P of B given A as? Yes, Jerome, can you tell me what is P of B given A? Does B, yes, Evelyn, you can also try. If does the happening of B depend on A, Evelyn?
Yes, sir.
Yes or no?
No, sir.
Yeah. Then what do you expect P of B given A to be? Like here, P of A given B was what?
P of B, sir.
Very good. This will be P of B itself. Very good. And that value is given to be 1 by 2. Correct? Okay. Now, can you tell me what is P of A bar? Having known what is P of A, can you now tell me what is P of A bar?
3 by 4.
Very good. Can you tell me P of B bar?
Half.
Exactly. See, because the moment you see this option, you should not tick that, right? You should also evaluate the other ones. So, can you tell me, yes, Jerome, you can try this. What is the meaning of P of A dash given B? How can I write it?
P of
Yeah,
A dash, sir.
that's all. Very good, because A dash and B are also independent. So, what is P of A dash?
3 by 4.
Very good. You can write it like this only when they are independent. I hope you got it. So that is also correct. Isn't it? So what about the third one? Third one, how can you write, Evelyn?
Sir, P of B dash.
Exactly. So let's come to that question now. Yeah, so P of B dash given A dash, you can write as P of B dash itself. So that is 1 by 2, correct? So all the three are correct, isn't it? Therefore, what is the right answer? All of these, isn't it? Should I repeat this or is it clear? Jerome, is it clear?
Sir, can you repeat it, sir?
Yeah, sure. So we start from here. See a P of A given B. Or you go from conditional probability, that's also okay. So I'm going to tell you by another way now. What is P of A given B definition, Evelyn?
P of A intersection B by P of B.
Correct. But what is P of A given B given to be?
P of A.
So now just using this, what is P of A intersection B? Just look into these two.
P of A into P of B.
And you know by definition, if P of A intersection B is equal to P of A into P of B, then A and B
A
are,
and B are independent.
is it clear, Evelyn?
Yes, sir.
Okay. So P of A is equal to what? 1 by 4 given, correct?
Yes, sir.
So what will be P of A bar?
3 by 4.
Correct, right? Now, going by the same argument, right? Now what is given? P of B, I'm sorry, 1 second. Yeah, P of B given A is given to be half. What is P of B given A?
P of A intersection B by P of A.
Isn't it? How can I write P of A intersection B because they are independent?
P of A into P of B.
So what is this equal to, Evelyn?
P of B, sir.
Exactly. So P of B, we got it as 1 by 2. So what will be P of B bar?
Half.
You got it, right?
Yes, sir.
Now going by, so A and B are independent is true. What will be this, Evelyn?
P of A dash.
Yeah, so that is 3 by 4, which is correct. And what is this?
P of B dash.
And what is that?
Half.
So all the three options are correct.
Yes, sir.
That's all. So we are using the formula which we know for conditional probability. That's also okay. Or directly also you can express the way I taught in the previous way. Whichever is comfortable for you, you can use.
Yes, sir.
Yeah, we'll move on now to the next. Okay, probability that a married man watches a certain TV show is 0.4. Probability that a man watches a show is 0.4. Probability that the woman watches the show is 0.5. The probability that the man watches the show, given that his wife does, is 0.7. What is the probability that a wife watches the show, given that her husband does? So what is asked here? P of W given H is asked. Very simple. Yes, Jerome. What is P of M given W? What is the formula?
P of M intersection W by P of W. Sir.
Very good. Very good. Now from this, I can find P of M intersection W, right? What is P of W? Already given.
0.5.
Yes. So what is P of M intersection W from this?
0.35. Sir.
Very good. 0.5 into 0.7, which is 0.35. Perfect. Now what is P of W given H? Formula?
P of W intersection H by P of H. Sir.
And what is P of W intersection H? Not H, I'm sorry, M.
M.
I just wrote husband. Okay, man. Okay. Tell me, ma. Is W intersection M, is it not same as M intersection W?
Yes, sir.
Yes. So what is the value?
0.35.
And what is P of M?
0.4.
0.4, right? I can write it as 0.40 as well, right? So 35 by 40. So if I divide by 5, right? This will be 7 into 5. Denominator will be 8 into 5. So what is the right answer?
7 by 8.
Yes. All of you got the answer? Is it clear, Aditya? Okay. Ritvik, is it clear?
Yes, sir.
Okay. Okay, we'll move on to the last question for the day. This is based on Bayes theorem, right? Very important type, right? In an entrance test, there are multiple choice questions. Okay. There are 4 possible answers to each question, out of which one of them is correct. Okay. The probability that a student knows the answer to a particular question is 90%. So let's represent that by K. So probability that a student knows the answer is 90%. Okay. That means what is the probability that he does not know the answer to a given question? Yes, Evelyn?
Sir, 10%.
Exactly. He knows the probability is 90%. He does not know it is 10%. If he gets the correct answer to a question, what is the probability that he was guessing the answer? Right? Okay. Now tell me one thing. He can get the correct answer in one of the 2 ways. Could you tell me what are those ways, Evelyn?
Sir, either he knows the answer or he was guessing and he got it right.
Exactly. Perfect. Perfect. Right? So first we will find out he got the answer correct. So let us represent it by P of C. So he got the answer correct, which means he knew the answer and he got it right. Or he did not know. That means he was guessing. And he still got it right. Perfect. That's what it means, right? I'm just writing it in words so that I know it's very clear to you, right? So probability that he knows is what? P of K. And is nothing but intersection, intersection and multiplication here. He's getting it correct given that he knows it. Or that's a plus because these two are mutually exclusive events. He was guessing. Guessing means he didn't know the answer. And he still got it correct. Okay, that's all. But this is not going to be a final answer. This is going to be the first part. It's called theorem on total probability. You have done
Sir,
it.
can you explain how it is C by K, sir?
Okay, well. See here, he knew the answer, correct? And he got it right given that he knew the answer, isn't it?
Yes, sir.
For example, correct? Is it not, Evelyn? For example, so this is nothing but K intersection C, right?
Yes,
Formula
sir.
for K intersection C will be P of K into P of C given K, correct? Both from formula perspective and idea also, right? Logic is
Yes,
clear.
sir.
Yeah. So what is the probability that he knew the answer, Evelyn?
90% or 90 by
90%, that's 90
100.
by 100. If he knows the answer, what do you think is the percentage chance of him getting it right? If you know the answer very well, what is your chance?
100%.
100%. Perfect. Now the next one. He didn't know the answer. What is the probability? What is the probability for that?
10%.
Yes. And if you did not know the answer, right? What is the probability that he got it right? If you don't know the answer, 4 options are there. What is your chance of success? If somebody doesn't know the answer.
25%.
25%. Very good. Jerome, did you get it? 4 answers are there. In that one option you have to choose and it has to be correct. Means what is your probability of success? 1 by 4, no? Or I can say 25%. Is it clear, Hartvik?
Yes, sir.
Okay. Aditya? That's all. Very good. So that's going to be nothing but we can cancel 1 0 here. 90 by 1000 plus 25 by 1000, isn't it? 115 by 1000. Is this what you're getting, Evelyn?
Yes, sir.
It's not 90, I think 900, no? I'm sorry. $900 by 1000 and 25 by 1000. So 925 by 1000. But that's not the final answer because what we want to get is he gets the correct answer to the question. Then what is the probability that he was guessing? So what is being asked here? Evelyn, can you tell me? You need to find the probability that
Sir, P of K by C, K dash by C.
exactly he was guessing. Probability of him guessing. Guessing means he did not know the answer, given that he got the correct answer. Yes, Jerome, from the formula, what does this represent? How can you write this?
K bar intersection C by P of K bar, sir.
Not K bar, ma. Whatever is in the denominator comes here. Yes, Jerome.
Yes, sir.
What is P of A given B? Tell me. No, tell me. P of A given B.
Uh,
What is P of A given B?
P of A intersection B by P of B, sir.
Right. What is P of B given A?
P of A intersection B by P of A, sir.
Are you clear now?
Yes, sir.
Okay. So therefore, what is P of K bar intersection given C?
P of K intersection C by
K bar intersection C. Not K. K bar.
K bar intersection C by P of C, sir.
P of
C.
very good. Very good. So this will be what? 1 second. So what is P of K bar intersection C? Is it not this part? That means what? K bar means what? He was guessing or he knew it? K bar means what, Jerome?
He was guessing, sir.
Guessing. And what is C? And he got it right. Correct? So this is nothing but this probability, right? So it is 25 by 1000 divided by P of C we already found. What is it?
925 by 1000.
Exactly. So 1000 gets cancelled. This is nothing but 25 into 37 because we know that 25 into 40 is what? 1000. 75 less it is. Therefore, 25 into 3 less. So I can write 925 as 25 into 37. So what will be my final answer, Jerome?
1 by 37, sir.
Exactly. So that's your answer. Is it clear, Evelyn?
Sir, I just have one question, sir.
Yeah, please.
Sir, in the start, we calculated the probability of he knew the answer and got it right, or he was guessing and got it right.
Correct. So that's called
Why
total
did we
probability.
do it together, sir?
Why did you do together, Evelyn?
Yeah, like why did we calculate the probability of both of them together?
Because those are all the possibilities in which he can get it right. Because it is clearly given that he gets the answer right, correct?
Yes, sir.
So what are all the possible ways in which he can get the answer correct? We have to include. Clear, right? That's why we are including both the things. He knew the answer and he got it right. Or he did not know the answer, he just guessed and got it right. So both we have to include. Is it clear to you, Evelyn, now?
Yes, sir.
Yeah, that's all. Okay, so good students. So that concludes our discussion on probability. I hope it's clear to you. And I will be sending across an assignment also. This worksheet also I will be sending it to you. Then the recording of this lecture also I'll send it to you. You can also review this so that it's very clear to you and practice more problems. Okay.